In today's video, I am going to solve KSET 2025 Physical Science question paper continuation. Yes. Let us start with the 30th question. What does the question says? The question says here, a uniform circular disk of mass m and radius r is rolling down a frictionless inclined plane that makes an angle theta with the horizontal. Then the acceleration of the center of mass of the disk along the inclined plane is. So they have asked to find the acceleration. So now the same diagram I have drawn here, the acceleration due to gravity they are showing downward. And this is the disk. A disk is having a mass m and radius r. Now the normal reaction will be always acting perpendicular to the disk. So the normal reaction will be acting like this, and mg, that is weight, will be acting downwards. So I need to split this mg into two components, that is horizontal components and the vertical components. So according to the geometry, if this is the angle theta means mg to this angle it will be theta. Okay, so it will be, this angle will be mg cos theta and this angle will be mg sin theta. So from here I can say that mg sin theta, which is equal to ma, that is a force acting, that is a f net force which is acting along the inclined plane. So along the inclined plane we have mg sin theta, which is equal to ma. M get cancels, that is the mass of the disk. They have kept it as a capital M, I took it as a small m, it is fine. So I got acceleration a, which is equal to g into sine theta. So from here I can confirm that option C is the right answer, that is acceleration which is equal to g sine theta. Yes, let us move on to the 31st question. An electron gains energy so that its relativistic mass becomes 2 times of m naught. What they have said, that mass took the form 2 times of m naught. Now its speed is, we need to find the speed they have given, we need to find the v value, and where c is the speed of the light. From the formula we have m, which is equal to m naught divided by square root of 1 minus v square divided by c square. What they have said, the m, it took the form 2 times of m naught, so which implies 2 times of m naught, which is equal to m naught divided by square root of 1 minus v square divided by c square. So here m naught get cancels, on cross multiplying I get 2 into square root of 1 minus v square by c square, which is equal to 1, on squaring on both sides. So I'll get the value to be 4. Root and square get cancels, so it is 1 minus v square divided by c square, which is equal to 1. So now I'll get a multiply inside everything. So I'll take this 4 to my RHS side. It will be 1 minus v square divided by c square, which is equal to 1 divided by 4, which implies, so I'll take v square by c square to the RHS side, 1 by 4 to the LHS side. So it is 1 minus 1 by 4, which is equal to v square by c square, or I can write down here 1 minus 1 by 4, which is equal to 3 by 4, which is equal to v square by c square. On cross multiplying I got v square, which is equal to 3 by 4 times of c square, or on taking square root, v, which is equal to square root of 3 into c divided by 2. So this is the answer for the speed. Yes. So from here I can say which option is correct. Option 1, that is square root of 3 divided by 2 into c is the right answer. Yes. Let us move on to the next question. What they have asked in this question, a bead of mass m is constrained to move under gravity along a planar rigid wire that has a parabolic shape, that is y, which is equal to x square by l. where x and y are the horizontal and the vertical coordinates respectively, the Lagrangian of the system. They have asked to find the Lagrangian of the system. What they have given? They have given the y value. So the y value to be equal to y, which is equal to x square by L. To find the Lagrangian, we have the formula Lagrangian, which is equal to kinetic energy minus potential energy. So, how to find this kinetic energy? Kinetic energy is nothing but half of the mv square. So, we have a Cartesian coordinates. So, it will be half of m into x dot square plus half of m into y dot square, right? So I am going to keep x dot square as it is. Instead of y dot square, what we have the y value, right? So we have y, which is equal to x square by L. Now differentiate with respect to time, so we'll get y dot, which is equal to 2 times of x divided by L into x dot. Why again x dot will come means even x is also variable. So that's why we will get dx by dt term. So substitute for y dot here, it will be plus half into m into 2 times of x dot divided by L whole square. It will be, on solving, what we get, half m into x dot square plus half m into 4 times of x square x dot square divided by L square. Yes, now let it be like this for a while. What is potential energy? Potential energy, which is equal to mgh. Instead of h, what we have? We have mgy. So substitute the value for y. So it will be mgx square by L. So after substituting everything in this first equation, so we get Lagrangian to be equal to kinetic energy, it is half m x dot square plus potential continuation half into m 4 times of x square x dot square divided by L square minus potential energy is mg x square divided by L. Now, in these two terms, I can take half m x dot square to be common. So, L, which is equal to half m x dot square. After taking common, what is left inside the bracket? It, in the first term it is 1, plus in that second term I have 4x square divided by L square. So remaining minus of potential energy, that is mg x square divided by L. So this is the final answer. We got Lagrangian to be equal to half m x dot square into 1 plus 4x square divided by L square minus mgx square divided by L. Let us go back to the question. So we have here option 2 to be the right option. Yes, can you see here option 2 is the right answer, that is m x dot squared by 2 into 1 plus 4x square divided by L square minus mgx square divided by L. Yes, let us move on to the next question and the final question for this session. A planet moves in a elliptical orbit around a star which is at one of the foci of the ellipse. Given that the ratio of the farthest distance to the closest distance from the star is 2, eccentricity of the orbit. So we need to find eccentricity, that is E of the orbit. So let us start with this question. In the question they have given, that is r of, that is the r of farthest to the r of closed to be equal to 2. So from the formula we have the farthest distance value, it is given by, farthest distance value is given by the equation, that is a into 1 plus e. So and the closest distance, it is given by, closest distance is given by the value a into 1 minus e. Yes, now on dividing, I'll get the ratios, right? I'll get the ratio, it is distance a into 1 plus e divided by a into 1 minus e. Now a get cancels, right? What is remaining from the question? We have farthest distance divided by closest distance value to be 2, 2 which is equal to 1 plus e divided by 1 minus e. Now cross multiply the terms. Here e represents the eccentricity 2 into 1 minus e which is equal to 1 plus e. Now taking 2 inside the bracket, 2 minus 2e which is equal to 1 plus e. On rearranging the terms, I'll get 2 minus 1 which is equal to e plus 3e. So on solving, I get e minus 2e. On solving, I get 1 which is equal to 3e, or e which is equal to 1 divided by 3. So I got the eccentricity value to be 1 by 3. So which is the right option? Option C is the right. Thank you everyone for watching.